Hello, welcome to our semiconductor education program. I'm Vincent Chang. I'm going to present an introduction to operational amplifier and also teach you about the modeling of operational amplifier. Operational amplifier is actually one of the most important systems in analog integrated circuit. Here's the symbol of OPAMP, which is short for operational amplifier, a triangle. It has two input terminals called differential input, a positive sign and also on the bottom, and also the terminal with the negative sign on the top. And the one output terminal. So it's the differential in and then single-ended out. Let me explain what do I mean by the differential in. The terminal on the bottom with the positive sign is called non-inverting input terminal, the terminal A. The terminal on the top with the negative sign is called inverting input terminal. The reason why we call the non-inverting and the inverting is because if the signal comes in through the positive side, the non-inverting, and then the phase won't change. And if the signal comes in through the inverting terminal, the signal will be inverted, means the out of phase. All right? So non-inverting and the inverting. So the configuration is differential in and then single-ended out. Differential in and the single-ended out. Power supplies. Most of the operational amplifiers has two power supply. So one on the top and one on the bottom. So the positive supply is denoted by V positive. The negative power supply is denoted, the one on the bottom, V negative. So let me ask you, where's the ground? Where's the zero voltage reference? Pay attention to the ground. The ground is actually the common terminal connecting to supply. The common terminal connecting the cathode of the positive supply and the anode of the negative supply. All right? So this is very, very important. Why this is important? When you said, let's say, the terminal A has 3 volts. What does that mean? That means the voltage difference between terminal A and the ground is 3 volts. Without the definition, without clearly defining the zero voltage, so any voltage won't make any sense. So in the future, most of the time, you won't see the ground, okay? So we use most simplified symbol on the left. Just put an arrow upward, V positive, and put another arrow downward, denoted by V negative. Ideal operational amplifier model. So I'm going to present a modeling of an ideal operational amplifier. Means the operational amplifier with an ideal characteristics. First characteristic, infinite input resistance, which means there's no current going through the op-amp. Infinite input resistance, no current input. And the second characteristics, zero output resistance, which means the output voltage will be fully depending on the one I'm going to show you the next. A voltage dependent voltage source, an ideal voltage source. Here it comes. An ideal voltage control voltage source This is the ideal voltage control voltage source. So where's the controlling voltage? VA minus VB, the term within the parenthesis. All right? So the controlling voltage is the differential voltage between A and the B. So voltage control, voltage source is the dependent source. Depending on what? Depending on the differential input. So you can write down these relations. VO equals A times the differential input, VA minus VB. So if the both input have the same voltage, VA equals VB, then VO is 0. So this nature is called perfect common mode rejection, which means this current system will reject the common part of the two input signal, will reject the common part of the two input signal and only sense what? Sense the difference part. So perfect differential amplifier also means the perfect common mode rejection. The fourth characteristics, infinite differential gain, means the A is big, it's the infinite. In reality, in let's say if the op-amp is built around the bipolar technology, then the gain could as high as 10 to the 5th power. And the last characteristics is infinite bandwidth. Infinite bandwidth. Just picture this in your mind. If this is, let's say, if this the vertical axis represent the voltage gain and this is the frequency. So infinite bandwidth means in the spectrum, the gain is constant. Means the gain won't be affected by the frequency of the input signal. Infinite bandwidth. So we have approaching the end of this lecture. So let me give you, just make 2 points. The number one, the summary. So you can maybe pause and take the notes. What's the 5 characteristics of an ideal op-amp? Number one, infinite input resistance. Number 2, 0 output resistance. Number 3, perfect common mode rejection. Number 4, the differential gain is infinite. And number 5, the last one, infinite bandwidth. And also you might be wondering, is there any operation amplifier is ideal? No any operation amplifier in the world can be found is ideal, all right? But why we teach you the ideal operation amplifier characteristic? Because it's simple, especially for beginner. In the future, in other courses, I'm gonna teach you about some of the non-ideal characteristics of the op-amp and their impacts on circuit performance. This is the end of the lecture. Thank you for watching.